Well, hello there, Chem 20s. We had a couple of students attend our weekly meet. And for those of you who couldn't, here's just a short video, some feedback on solutions. We had a formative last week, and we're going to be learning some new stuff this week on pH, pOH, and solution stoic. So this is kind of our lead up to stoic, is being able to convert from mass to concentration or mass to volume. Here's an example of a question where you were given the mass in grams. And so that's what you start with. You start with the mass, and you see that we have grams. And so we use the molar mass, and we have to invert it, right? To get the grams to cancel, it has to go on the bottom. So we're actually not timesing, we're actually dividing by the molar mass. And of course, you calculate the molar mass by going on to your periodic table. You look up molar mass of sodium and oxygen and chlorine, and the molar mass is 74.44. So that might have been where you made an error. So we've got mass divided by molar mass to give us the number of moles. And then they're asking for how many liters. So when you're given a concentration, understand that concentration is a conversion factor, much like molar mass is, and you can flip it around, right? So if you want to cancel out liters, you would go like this, 0.80 moles per 1 liter, and then the liters on the top and bottom would cancel out. But in this case, we've got to flip it around. We have to invert it. And so we've got moles on top, and to cancel moles on the bottom, we have to flip it around, and then that leaves liters on top. And so then we go back and we round our answer. So we've got 2 sig digs here. And so our final answer has to have 2 sig digs. So when I round it, it's 2 liters of sodium hypochlorite. And of course, that's chlorine bleach. So I don't know how students came about with some of these. Maybe they multiplied by molar mass instead of divide, or maybe they multiplied by concentration instead of divide. But this is something you have to get quite familiar with. So do some practice on these questions and be able to figure that out. Now, I know exactly where the student went wrong on this question. I had almost as many students select this incorrect answer as the actual correct answer, which was C. And the error was in this, is that students looked at this and they said, oh, I've got iron 3 sulfate, and I've got this mass, so I'm going to take my mass, and that's grams, and then I'm going to go, well, every 1 mole has blah, blah, blah grams when I get the molar mass, and then I'm going to divide by the number of liters, and that's going to give me my answer. Well, I think you didn't read it carefully. I'm not looking for the solute. I'm looking for the sulfate ions. So you have to write out for this one a dissociation equation, right? Once you go, and you were on the right track, right? You got part of it done, right? Is that you had your mass and you canceled out grams divided by molar mass. Now I've got moles. I've got to divide by liters to get concentration. That's this guy's concentration. But the question is asking you about the sulfate ions. And so you have to write out your dissociation equation to show that this ionic compound breaks up into its ions. And there's 3 moles of sulfate for every 1 mole of this iron 3 sulfate. So all of you who picked A, maybe you just saw it on your calculator and you're like, oh yeah, here's my answer. Well, no, you forgot the mole ratio. I times by 3/1. And then my actual answer, C, is correct. Okay, so a lot of students there either didn't read carefully or didn't realize that they had to move on and find the sulfate ions. Okay, by now you guys should be pretty familiar with seeing a question like this. The old labels got washed off the beakers in the lab, and here's these 4 solutions, and you have to figure out which solution is which. And so you've got HCl, which we know is an acid. You've got NaOH, which we know is a base. Here's our neutral ionic compound, salt, sodium chloride. And then I think a lot of people look at that and they say, oh, this is OH, this is a base. No, it's not. This is a molecular compound. How are these 2 things different? How can I say this guy's a base? He has an OH. Well, so does this guy. Well, what's different is that this guy has an metal, right? This is an ionic compound. Bases are ionic hydroxides. This guy has no metal. We've got the nonmetal carbon, we have the nonmetal hydrogen, and then these are not ions. Molecular compound, these are molecules, not ions. So because they're molecules, they're non-electrolytes. They have no conductivity. So that explains why methanol, ethanol, any alcohol is a molecular compound that will not conduct electricity. So he doesn't change litmus. Another guy who doesn't change litmus but yet is highly conductive. Why is that? Because he's ionic. And so that has to be the sodium chloride made of sodium ions and chloride ions. And then looking at litmus, if blue goes red, we know it's an acid. So there's our acid. Red goes blue, we know it's a base. And so that's number 3. Okay, so we've seen that question in various forms. Be expecting to see that on your summative as well, right? Pretty important concept in this unit. Now remember, when I'm asking you about modified Arrhenius theory, it's not the original Arrhenius theory, right? They're two different theories. The original Arrhenius theory said an acid was an acid because it has hydrogen in it. And he said a base is a base because it has hydroxide in it. All right, but modified Arrhenius is the whole reacts with water theory. And so we understand that things like NaOH, well, that's easy to understand that why that is a base. It has hydroxide on it. But if you dip a piece of litmus into some ammonia, red litmus goes blue. And it is also conductive. Well, why is that? It doesn't have an OH on it. So we have to explain it based on the modified Arrhenius theory. So this ammonia is going to react with water, and that's the whole reacts with water theory. The hydrogen from the water is going to join up with the ammonia to form ammonium ions. But more importantly, we're making hydroxide, and now that explains why it's a base, right? So if you tried doing this and you decided, well, what if I am making instead NH2 minus, that thing does not exist. So if you think that the hydrogen is going here and you're making an acid, well, that is not true. You can look up, you know, this is a polyatomic ion on your chart. You know hydroxide is a thing. So although here we know that hydronium is a thing, NH2 does not exist. So that cannot be one of your answers. Okay, so ammonia is a base, and that's something you should know. And I know that my Science 10s last year, this year, well, not this year, but in the past, we do a lab where we actually test with litmus and see what is ammonia. Is it an acid or a base? Okay, so you need to memorize that ammonia is a base, and this is the reason why it is molecular, but it reacts with water. It's a modified Arrhenius base. It reacts with water to produce hydroxide ions. Okay, so this week we're doing pH and pOH calculations, learning how to calculate hydronium and hydroxide and convert between all these different things. I have supplied you guys a handout sheet that has all of these formulas. You also have it in your notes and your textbook, and it is also listed for you on that extra data sheet. And so the most important thing is to pay attention to significant digits when you are doing these questions. So here's an example of, they're giving me the hydronium ion concentration. So they're telling me here's the hydronium ion. And now I have to pay attention to how many sig digs is there in this concentration. Well, it's a concentration, right? So that doesn't count in the value of the concentration. Here's a digit. Here's a digit, here's a digit. So this is a 3-digit concentration. That means that my answer has got to have 3 sig digs. Now, the thing about when you do pH is that the sig digs only count after the decimal place. So anybody out front of the decimal place, we don't care about. Honestly, they don't matter to us at all. It's these guys after the decimal place. So in this example, our final answer is going to be something decimal. Who cares about the something? It's these guys after the decimal that are important. So on your calculators, you find the log button, you go negative, and then you hit the log button, and then a bracket pops up. And then you punch in 2.34. And then how do you get an exponent? Times 10 to the power. That's your second EE or your second comma. And then you get the little E. That means you now have an exponent. And then you again press the -5, end your bracket, hit enter. And ta-da, you now have this value come up on your calculator. So if you're asked for a final value for pH, we need to have 1, 2, 3 values after the decimal. I don't care about the 4. It does not matter to us. That means that the 7 is going to cause that to round up. So our final answer, and this is the correct 3 sig dig answer, 4.631. Now, if you're asked to move on and calculate the pOH, now remember that these two scales are opposite of one another, right? If I have the pH scale, it goes from 0, 7 to 14. And I know that all the neutral things are around 7. My strong acids are going to be closer to the 0 end of the scale. My weak acids are kind of in between there. My weak bases are kind of in here. And my strong bases, those guys with hydroxide, are going to be way at the far end there. So the pH and the pOH scales are just opposite of one another. So now if I want to find the pOH, well, 0 plus 14 is going to give me that. And so this guy will be 7 and this will be 0. Okay, so the pH and the pOH scale, they add up together. pH plus pOH are going to add up to give you 14. So remember, don't round until the very end. You have all these digits on your calculator, go 14 minus that value, and then you round at the end. And who cares about the 9? I don't care about the guys in front of the decimal. Here's 1, 2, 3 significant digits. And finally, from there, if you're asked to find the hydroxide ion concentration, it is 10 to the minus. So that is second function or inverse log. Okay, and when you do that on your calculator, you get 10 with a little, it looks like a little hat like that. And then you type in negative and then all those values, 9.6, blah, blah, blah. Okay, and so at the very end, you have to have 3 digits in your answer. Now remember, this is a concentration. So all the digits count. It's not a pH. It is going to include all the digits. So there's my 3-digit significant digit answer. Okay, I'm going to come back with a video on solution stoich. This is it for now, so be ready for another video in just a couple minutes. Okay, take care.